Okay, the third type of separation is separation by ion exchange. So the mechanism will involve exchanging of ion. Okay, so the ion of interest, which is in the solution, okay, will be exchanged with the ion that is held in a porous and insoluble solid here. Okay, the chelating resin. Okay, when they are brought in contact. Okay, let us look at the application, okay, to understand this better. So the first application used to eliminate ion that would interfere with analysis. So what does it mean here? If you go back to the third learning unit, which is gravimetric analysis, okay, we want to precipitate barium sulfate, okay, but during the precipitation of barium sulfate, it has the tendency to co-precipitate also if other cation are present, for example iron 3 or aluminum 3. Okay, so the co-precipitation is one of the 5 interference that you have studied. Okay, so how we can overcome this? Okay, so let's say the solution, okay, solution through this tube here, that solution have sulfate inside, okay, and the resin here it have a hydrogen ion. Okay, so in this case we are talking about cation exchange resin. Okay, so another one is anion exchange resin. Okay, so in this case the sulfate, the cation in the solution, will be brought in contact with the chelating resin here, which will have the hydrogen ion. Okay, so therefore that hydrogen ion will exchange with sulfate from the solution here. So sulfate will be retained in this chelating resin. Okay, and then hydrogen in the solution here will pass through. Okay, and then later on that sulfate can be washed through this resin and precipitate with barium. Okay, so that is one application. The second example of application is used for concentrating ion from a very dilute solution. Now, let's say we want one ion, but that ion is present in a very small amount because the solution used is very dilute. So what we can do is we can pass through the solution here, okay, and then the ion of interest will be retained in the resin, and then later on once it collected, you can concentrate them. Okay, once collected in the resin. For example, we want to collect traces of metallic element in natural water. Okay, again we use cation exchange column. Okay, and then once we get the metallic element trapped inside the porous resin here, we can wash it with acid and to collect it. Okay, to collect it, and what we get is the concentrated metallic element. The third application is used to remove salt content in the solution. Okay, this can be done by titration. Okay, titrating the hydrogen ion release, okay, as an liquid of the sample pass through. Okay, so we pass through the sample, okay, here, okay, in the again cation exchanger. Okay, and then using standard hydrochloric acid solution, dilute it to a non-volume. So the effluent of the sample can be collected. Okay, so the advantage of this ion exchange is easy, okay, faster, okay, it can remove the interference element, and has the ability to concentrate in a light of interest. So these are the example. Okay, so I have explained this just now. Okay, um, the first application, the second application, then the third application. Okay. Okay, the fourth type of separation is chromatographic separation. So what is chromatography? Okay, so it's a technique for separating mixture into component, so that we can analyze, we can identify, we can purify, and even quantify the mixture of the component. Okay, so we have mixture here, and then we undergo chromatographic separation, we get the individual analyte, okay, the component inside the mixture. Okay, so it is used by scientists to analyze. Okay, we examine a mixture, its component, and their relation to one another, identifying the mixture component, okay, purifying the component, okay, and then we can quantify. Okay, quantify mean the amount of individual component in the mixture can be identified. So there are several types of chromatography. Okay, the first one is liquid chromatography. Okay, liquid chromatography involves separating liquid sample with a liquid solvent. Okay, solvent will act as the mobile phase, and then we use column, which act as the stationary phase. Okay, later on we'll see the detail of liquid chromatography. Second is gas chromatography. Okay, this one will separate vaporized sample with a carrier gas. Okay, so gas will act as the mobile phase, which will carry the sample that has been vaporized, okay, through a column, and that column is the one that acts as a stationary phase. Okay, normally gas chromatography will involve the use of sophisticated instrumentation. The third type of chromatography is paper chromatography. So paper chromatography will separate dried liquid sample with a liquid solvent that acts as the mobile phase, and the stationary phase would be the paper strip. Similarly, thin layer chromatography also the same mechanism. Okay, separate dried liquid, only that the stationary phase is a glass plate covered with a thin layer of alumina or silica gel. Now, these are the common term in separation technique. Stationary phase. Okay, stationary phase means a phase that is fixed in a place, either in a column if it involves liquid chromatography, or on a planar surface if it involves thin layer chromatography or paper chromatography. Okay, mobile phase is the one that move. Okay, phase that move. Okay, so this phase move over the stationary phase. Okay, and this mobile phase will carry along the analyte of interest, the one that you want to study. So the third term is eluent. Eluent is a solvent used to carry the component, okay, of a mixture through stationary phase. In another word, eluent is the mobile phase. Okay, so these are the different type of chromatography. If the nature or mobile phase is gas, okay, then the stationary phase is either liquid or solid, and the mechanism will depend on the stationary phase. Okay, the technique involved is column, and the name will depend on the stationary phase, um, as well as the mechanism. Okay, if the mobile phase is liquid chromatography, the stationary phase will be either liquid, bonded liquid, or solid, and mechanism will be different. Okay, so that's the technique, and the name will derive based on the stationary phase, as well as the mechanism and also technique. Okay, so um, the one that you should focus is thin layer chromatography here. Okay, um, okay, here also have thin layer chromatography. The difference is in terms of the stationary phase. Okay, whether it's liquid or it's solid. Okay, high performance liquid chromatography, we have this here in the faculty. Okay, HPLC. um, and we have GCMS also, and GCFID, gas chromatography, mass spectrometer, gas chromatography, flame ionization detector. Okay, don't worry so much of this. Okay, I don't expect you to memorize the nature of the mobile phase, the nature of the station phase, and so on. I just want to show you how does the name come from. Okay, derive from. Okay, so it depend on the mobile phase, stationary phase mechanism, as well as the technique. So chromatography comes from Greek word, which is chroma. Chroma means color, and graphene, okay, means to write. Okay, so separation method, is the difference in partitioning behavior or migration rate between a flowing mobile phase and a stationary phase to separate the component in a mixture. Okay, for liquid chromatography, column will hold the stationary phase, and the mobile phase is poured on the top of the column, and this mobile phase will carry the sample through it. So how does it work? Okay, so of course sample is loaded on the stationary phase, and it works as the principle on the basis of principle: polar likes polar, non-polar likes non-polar. So if the component of interest is having polar compound, then that polar compound will have interaction with the polar stationary phase compared to the non-polar. Okay, so the polar will be retained by the stationary phase, while the non-polar component will go go through. Okay, so mobile phase will act as the eluting phase, which means it will help to push or elute the compound either down a column for liquid chromatography, okay, or column chromatography, or up a plate through capillary action for thin layer chromatography. Okay, so if you have polar component, it will be attracted to the polar stationary phase, because why? Stationary phase is made up from silica gel. Okay, silica gel SiO2, so they are um, polar component, and this will have intermolecular force, okay, which is called dipole-dipole interaction. Okay, yeah, you see this dotted line, so that is intermolecular force. Okay, so the non-polar compound of course will travel more easily because it is not attracted to the stationary phase. Okay, and how it will travel? Through mobile phase. Mobile phase will carry them. Okay, so why separation is possible? Because different compound will have different polarity. Okay, so the non-polar will elute first, while the polar will elute last, because it will interact. Okay, they will interact with the polar stationary phase. Okay, let us look at one example here. Okay, column chromatography. So column chromatography, stationary phase is this one, made of the packed fine solid. Okay, it's fine silica solid. Okay, mobile phase is injected here. Okay, which will carry the analyte of interest. Okay, remember, different component have different polarity. Okay, those which is more polar will be retained stronger to the polar stationary phase. So that's why you see initially the mixture is composed of component A, B and C, but they have different interaction with the stationary phase. Okay, so it will begin to separate from each other. Okay, so C will move faster because this is non-polar. So non-polar, less interaction with the polar stationary phase, so it will move faster. Okay, with the mobile phase, of course, followed by component B, and lastly, most polar compound component, most polar, most polar component is A. Okay, so it will elute last. So we can collect C first, followed by B, then A. Now for paper chromatography, okay, it moves based on capillary action. For column chromatography, it moves by gravity action. Okay. So this paper chromatography is quite quick, okay, because it only requires small quantity of material. Okay, so the stationary phase is a piece of high quality filter paper or highly porous paper. Okay, mobile phase will be the solvent used, okay, which will travel up, okay, the stationary phase, carrying the sample with it. So this is the cellulose unit, okay, of filter paper. Okay, so filter or porous paper is made of cellulose. Okay, so these are polar. So this is how it is done. Okay, for paper chromatography or thin layer chromatography, a fine line, thin line, draw with a pencil here. So this will be the starting line. Then ink spot will be centered and evenly spaced on this starting line. Okay, you notice that the line and ink must be above the liquid level. So this is the liquid level, it has to be above. Okay, and then we put the mobile phase here, which is the solvent, okay, the liquid, made of ammonia, butanol, mixture of ammonia, butanol and water, okay, in this case. And then another line was drawn here, okay, thin line, which will indicate the finish line, or we call them solvent front. So once this mobile phase has reached this line, we take out this paper or thin layer chromatography out of this beaker. Okay, note that we must cover the beaker, okay, so that we want the solvent to be concentrated only in the beaker without vaporizing out. Okay, so after the mobile phase has moved upwards through capillary action, the first three spot, okay, looks like single component, okay, the red one, the blue one, and the turquoise. Okay, however, for the fourth one here, we can see a separation. Okay, so separation. Okay, two dots was identified here. Okay, and the solvent front is measured from this distance. Okay, the first line here, starting line, to the solvent front. Okay, so that is how the movement of the solvent. So the theory behind paper chromatography or thin layer chromatography, so they work the same mechanism. Small sample of a mixture placed on a porous paper or thin layer chromatography, okay, means silica coated on glass or aluminium. Okay. This will be in contact with the solvent. Okay, the solvent which will act as the mobile phase, okay, move upwards through capillary action, and at the same time it dissolve the mixture. Those components that have stronger attraction with the paper will move slower. Okay, those with low interaction will move faster. Okay, go back to the concept. Polar likes polar, non-polar likes non-polar. Okay, capillary action. What does it mean? Movement of liquid to the force due to the forces of addition, cohesion, and surface tension. Okay. Solubility is the degree to which material or solute dissolve into solvent. Okay. Separation of component will depend on both solubility in the mobile phase as well as the interaction with the stationary phase. Okay, thin layer chromatography, similar like paper chromatography, is a solid liquid technique. Okay, there will be two phases, which is the solid stationary phase and a liquid mobile phase. So the solid commonly used are silica and alumina. Okay, and both of these are polar type of adsorbent. Okay, the difference is silica is acidic, alumina can be neutral, basic, or acidic. So different component in mixture will move up a plate at different rate due to the differences in their partitioning behavior between the mobile phase as well as the stationary phase. And we can visualize the separated spot under UV light or using iodine vapor method. So this is the silica, okay, for thin layer chromatography, okay, the stationary phase. This is the alumina. Remember, alumina can be either acidic, neutral, or basic. To make it acidic, we have the aluminum OH group. To make it neutral, we have aluminum hydroxyl group and also aluminum oxide group. Okay. Basic, only made of aluminum oxide. So basic, we don't have this upper part here, only the lower part here. Okay, so the presence of this will indicate the whether it's acidic, neutral, or basic.